So when it comes to statics, we're going to be talking about forces, and where the forces come from, the idea of forces come from, they come from Newton's three laws of motion. And Newton's first law is the one we're going to be looking at in this video. And it says, in an inertial reference frame, an object either remains at rest or continues to move at a constant velocity unless it acted upon by a force. So, let's first define an inertial reference frame. So an inertial reference frame is basically a reference frame that doesn't move. So you could think of it like as the ground or as like maybe the earth or something. But if you look at a scope larger than the earth, you would notice that the reference frame of the earth is actually moving. So, but on a relative sense, we could ignore that fact because, the earth is very large and its motion does not affect our problems. So, we could say an inertial reference frame, which is basically a frame that's not moving, a reference frame not moving. And then the rest of it says an object either remains at rest or continues to move at constant velocity. So an object has this idea of inertia, the idea that it doesn't want to move unless you apply a force that's large enough to get it to move. So once you apply that force and you accelerate it and you stop applying that force, it will move at a constant velocity forever. The only reason why we don't see it on Earth is because we have external forces that act upon the object, which cause it to slow down and decrease in speed. So a good example would be like, let's say you have a box, and you apply a 10 Newton force on it, onto the ground. This is our reference frame. The ground is the reference frame. Usually when you see this notation, the slanted lines on a wall or on the ground or something like that, that defines that it's not moving. So based on this reference frame, you apply 10 newtons. But because in our world there's frictional forces due to the weight or the contact force between the box and the ground, it causes the box to keep moving and then completely slow down sometime later. So not moving anymore. And that's because there's friction being applied at where it's contacting the ground. But if there were no friction, no external forces, and you apply this 10 Newton force very quickly, the box will stay in motion forever. And then obviously in this class we're looking at static systems, so that means systems that don't move. And basically we're going to look at systems that have applied forces on them. So we're going to have forces that are applied, so F1, F2, F3, and so forth at different angles and different magnitudes. But we're going to notice that although all these forces are applied, the net force, or when looking at the whole object as a whole, it does not actually move. So that is the main topic for this course.